Scalars in vectors. Most of physical quantities in mechanics can be represented by their scalar or vector quantities. A scalar quantity is like a mass, time, volume, length, are represented by scalar quantities. They only need magnitude when they are represented. A vector quantity has both magnitude and direction, like a force, velocity, acceleration, and they are called vector quantities. Vector addition. Two vectors A and B can be added to form a resultant vector. It means R equals A plus B by the using parallelogram law. If the two vectors are collinear, it means both vectors have the same line of action. The resultant is formed by algebraic or scalar addition. Vector addition of forces. A force is a vector quantity since it has specified magnitude and direction. Constantly, forces are added together to resolve into components using the rules of vector in algebra. Two common main problems in statics involve either finding the resultant forces given its component or resolving an unknown force into components. Often the magnitude of a resultant force can be determined from the law of cosine, while the direction is determined from the law of sine. Components of a force. Forces acting at some angle from a coordinate axis can be resolved into perpendicular forces called components. The component of a force parallel to a x-axis is called the x-component. Parallel to y-axis is called the y-component. So here we have x-coordinate, x-axis and y-axis. X-axis and y. So in here we have a force in this direction. We name it F. And for dividing this force to its coordinates, we could do it in multiple ways. Like one would be the x-axis, like we will name it Fx, and the y-axis we could name that Fy. And another we could use here, this would be the Fx, and this would be the Fy. Both have the same meaning, and here we have the angle theta x, and here we have the angle theta y. And to find the coordinates, like first would be the Fx. We will find the Fx. Fx is equal to force times cosine of theta x, and when we get is equal to, we could find it in two ways. Both have the same, we'll get the same thing from them, like f sine of theta y. If we get theta y, and another is Fy. So Fy is equal to F times sine of theta x is equal to F times cosine of theta y. So what I mean, like these two are equal, like suppose this angle theta x is equal to 30. So when we get the cosine of 30 is equal to cosine of 30 is equal to sine of when we the whole system is 90 degrees. So when we divide 30 from 90, we'll get 60. So it's equal to sine of 60 degrees. Because of this reason, this sine of theta y is equal to cosine of x. And to find the resultant, or the force, the F is equal to the square root of fx squared plus fy squared. And if we want to find the angle, the theta. So we will use the tangent theta x is equal to, when we find one we could divide and find the other angle as well. Fx is divided by Fy. So here we have another problem, like we have the x-axis and y-axis, and the forces have these kinds of numbers, like so here is letters. So in the real example we would have numbers instead of letters, like a V, R and H. So for this to find the angle, so when you have these numbers, these kinds of things, we're not gonna have the angle. So to find the angle we use the SOHCAHTOA. It means sine, cosine and tangent. So for this, so this is the adjacent, opposite and hypotenuse. So to find the, for fx, to find the cosine, so the cosine we don't have the angle, so we use the cosine. So we'll use instead, we will use the, like for cosine we'll use the opposite, adjacent divided by hypotenuse. It means we will get like a h divided by r. This is v, okay? And to find the fy, we will use the force r, no, v, it's v divided by r, to find the, instead of this we will use instead of cosine, and this we will use instead of sine. And when we find the, so to find this thing is equal, like when we find the, how to find the hypotenuse, we will square root everything, like the h, that means the adjacent, square plus v, the opposite. When we, from this formula you can find the resultant, it means you can find the r. So here we will find the components of a force in 3D, in 3 dimension or in 3D space. Like first I will draw the axes, the x, this is the y, and in this direction is the z. We have 3 components in a 3 dimension. So suppose we have a force that acts in this direction, so this is the force, okay? And to find, so suppose, so and the previous we had a force, we were finding the force in 2 dimension, means we had just x and y axis, and here we have to find in 3D, so we have 3 components, fx, fy and fz. So we will draw the components. The components would be something like we will draw it something like so this would be the fy, okay? The fy, we will draw from here another thing, it's the fx, another component. We could and from here we could have the fz. So this would be the, and we could draw something like another, and like this also, like this. We will do something like this, and we go up here, and so this is the point that the vector is in this direction. We could assume that it's this force is, the vector A has 3. Vector A has like a 3 components, x, y and z. And now we will find the components, like we will use the fx. It's equal to, when the fx, we will find the force will multiply with cosine of theta x. And to find the y component, fy is equal to force times cosine, yeah, it's the cosine of theta y. And to find the fz, so the force will multiply with cosine of theta z. And to find the resultant force, we can find the force is equal to, we will get the square root of fx squared plus fy squared plus fz squared. And to find the angles, we will use the cosine of theta x. To find the x for theta x, cosine, will use the fx divided by f. And to find the cosine theta of y, we will use the fy divided by y. And to find the cosine of theta z is equal to f z divided by f. And